Okay, so first thing first is we separate out this way. We created our regression in this way. So 0, 1 and x1 minus mu 1. Plus, we can do the many of them, so x a0k and xk minus mu k plus u. So actually this is the, we have all individual items, xi, this is I will use I later. Ki, okay, ui and 0. And y1, when this is, so we are separating out the two regression model, one for w is 0, one for w is 1. This is 1, 1, right? x1i minus mu 1. This is a first variable, and then this is a one individual, right? So this is an individual. Plus, and we will have a same thing, so a 1k xki. This variable will be the same. So in this form it looks weird, but actually this is still fine, because if you just calculate it, this mu is the average of the variable xi. So this is the fixed number. So if you multiply this and this can be observed into the here, and this times this can be also go into the intercept part. Now, what would be the average treatment effect will be expected of the average treatment effect is expected value of the y1 minus y0, right? So what is the expectation of the difference between the when we do the treatment and when we don't do the treatment? What is the difference, right? So we know the yi, we can create this one is yi0 minus wi1 minus yi0. Yeah, I already explained that. So when w is 1, this will go out, and then right, this is plus, right? Then yeah, it will be just y1. When w is 0, then this is a 0, then this is just y0. So we just write down y, right? And this one, if you calculate this yi using this formula, just replace this one. What we can get is b0 plus a01 x1i minus mu 1 plus, right? I will not write down everything. So xki minus mu k plus u I0, right? This is this one plus wb, this is a 1, so it's a b1 plus wa11 x1i minus mu1 plus plus w a1k xki minus mu k plus wi1 minus WB0 plus WA01 x1I minus mu1 plus dot 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 W minus W, because there's minus here, minus A0K xki minus mu k. Again, this is minus, but it's not that important. Right? If you rewrite this one, actually this is like a B0 plus B1 minus B0 W plus, if you take a look at it here, this is the A01x1I plus minus A01 mu1, right? Plus, and then you will have a lot A0K x k I, right? Minus A0K mu k plus, and then the W, if you consider the W and this is the same, so you can, these two becomes W times, no, I will write this one first. This one will be the A11 minus A01 times W times x1I minus mu1 plus, you will have a lot of same thing, and A1K minus A0K and W times x ki minus mu k plus u. Actually the u is an error term, so we assume that this is the error term, even though this has like a w and so on. So altogether you can just use it, this like a u I, right? So basically this is also the regression term. What we are interested in here is what is the difference, the expectation of the difference here, right? So expectation of difference is when you take a expectation of y0, this will be 0, right? Because the expected value of the x is the mean, so this will be gone, this will be gone, everything will be gone. Only thing left over is this b0 and b1. So expectation of the expected value of the y0 is the b0 here, and expected value of y1 is the b1. So I want to know the difference between these two. So this is the average treatment effect, and then this is basically the b0 minus b1 minus b0, because the b1 is the when we have an effect. This is the actually what we want to find out, right? So if you take a look at it, in this regression, this is the what we call the tau, and this is the expected average treatment effect. So that's why I already told you it's a W times something minus mean value, including this variable, also variable. What is this term will be? Because this mu is the average times the parameter, this will be observed into the here. This will be the term, but this one is also the constant number, so it will be observed into the here. So altogether, this one will not be the b0. You will have a b0 plus minus a and mu and so on. So you will have a lot of them. That will be the intercept. So what in this regression, intercept will not be the B0, will be the B0 minus A01 mu1 minus A. I will do the dot 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 minus A0K mu K, right? So, but however, what I'm interested in this one, I want to know the expected average treatment effect, and that is the what we are looking for is a B1 minus B0. That's why we have to run this regression, and then find out tau, and then we can estimate what is the average treatment effect. Okay, that's why we have to run the regression this way, right? Again, this is not the B0, this is alpha, new thing, and we're gonna get here, and we're gonna get all this, and then now it's a W times xi1 minus, yeah, they use the indication, the opposite way I use, but minus mu. The problem of this mu one, I cannot, we cannot get the real average, so we will use the x bar. Right? Just replace x bar and then run this regression, and then you got a tau. Then this tau will be your expected ATE. That's why this is the estimated coefficient. Okay, so I will show you the